Hey, GAP Math students, this is video for Intro to Geometry, notes for objectives 8 through 11. I think we have a total of 10 or 11 problems to do today, but I think this section should be a little quicker, a little easier than the last couple. It's some stuff that you're probably familiar with. Grab your packet. If you don't have your packet, hit pause, go grab your packet, and turn to this page that starts with objective 8. So it's objectives 8 through 11. So we're going to be looking at perimeter of quadrilaterals and circumference of circles. So we have a little bit of notes to take in the beginning here, and we're going to look at first perimeter of quadrilaterals. So quadrilaterals are just four-sided figures. So we're going to take just some quick notes here. So if we're looking at perimeter of quadrilaterals, you can't read that, it's written on by the objectives. Perimeter is distance around, so that's first of all. So one easy way to think of that is if you had to like put a fence around something. That's perimeter. So perimeter of quadrilaterals, there's a few different ways you can think of this. If you just have any old random quadrilateral, one way you can think of it, and this works for all of them, is you just add all sides, all four sides. So if you have a quadrilateral, let's say it's not a square, it's not a rectangle, it looks something like this, it's just oddly shaped. You have just the sides, sides 1, sides 2, sides 3, sides 4, and you just add them together. Okay? If you have a rectangle, and for this matter would work for a square, there's a formula you can use. So let's say that's a rectangle. You have the width and the length. You can go 2 times the width plus 2 times the length, and that'll equal your perimeter. Okay, and that's just because, again, you could add all the sides, but W and W are the same, so it's the two widths are the same, so that's why you just take 2 times that. Length and the length would be the same, so you take 2 times that and add them up. Okay. Then the third kind of special case is for a square. You can definitely do either of these 2 steps. You can add all the sides. You could do this even though the width, with the square, the width and the length are going to be the same. So let's say that's a square. So you just have S, because all the sides of a square are the same. So you could say 4 times S equals perimeter. That's just a special case. Okay. And then for parallelogram, it's basically the same as I'm trying to forget. I forget how to spell parallel. I think that's wrong, but parallelogram. So what a parallelogram, it's kind of like a rectangle. It looks like this. You can do the same, and we can just name them like side 1 and side 2. And the opposite sides are the same. So side 1 would be the same over here, side 2 would be there. So you could just do, let me erase that. You can do the same as for a rectangle. 2 times side 1 plus 2 times side 2. So this should be it. It looks like. Let me erase again. That looks like a Z, and it shouldn't be. Make a better looking 2. Okay, so what we're going to do, we're not going to do the problems in order. I'm going to do them kind of, we're going to skip around a little bit and do ones that are similar first. So we're going to do all the ones with quadrilaterals that I want to go over first, and then we'll go look at the ones with circles. So 43, this is a parallelogram, opposite sides are parallel. You're going to just, you can do this, or you could, you could label this, whoops, sorry, again, eraser. Opposite sides of a parallelogram are the same, so this would be 6, this would be 7. This 4 is not needed, that's not part of perimeter. Eventually when we look at area, you would need that. So we could just add all the sides, that would equal 26, or we can go 2 times one side plus 2 times the other side. So that would be 12 plus 14, and that equals 26. Okay, so either way there. Okay, we're gonna, like I said, we're gonna skip around a little bit. So if we turn the page, I'm not gonna do. Okay, again, if I'm going too fast, hit pause, find the problem I'm talking about. I'm not gonna do this whole problem, but I'm just gonna show you how this problem will look like the one we just did. It says one side of a parallelogram has a length of 4.5 kilometers, while another side has a length of 56.6. What is the perimeter of the parallelogram? So again, it doesn't have to be perfectly drawn to scale, but this is going to be, again, parallelogram. It's going to be kind of a long, skinny one because it says 4.5 and 56.6. Okay. So all I'm going to do on that one is just draw the picture, and then you can use one of the 2 ways I did problem 43 to find the perimeter there. And again, the answers are in the back, so you do that one, you can check it and see if you did right. Okay. And sorry for all this turning back and forth on your papers, but we're going to go to 61. So again, if you want to hit pause, turn the page until you get to 61. This is going to be like the one we did first, so when you practice, you can try that one. That should be easy. 61, I just want to do, because sometimes people, they freak out when they see fractions or whatever. So I just want to show, like, this isn't a big deal because there's fractions, and also because it talks about a square. So there's 2 things going on here. It says find the perimeter of a square whose sides are 14 1/4. Okay. So again, that's not a great square, but remember, 14 1/4, if you don't like working with fractions, let's change this to a decimal. 14 is the whole number. Change this to a decimal. Anytime you have a fraction, you want to change to a decimal, you take top divided by bottom. Plus, this should be the one, this should be one you just know what 1/4 is, but if not, top divided by bottom, so 1 divided by 4 is 0.25. Okay, so the side of a square is 14.25, and because it's a square, all 4 sides are. So there's 2 ways you can do this. You could hit 14.25 plus 14.25 and so on, add that 4 times. Or on that first page, I said the area of or the perimeter of a square is 4s. Well, s in this case is 14.25. When you multiply that, you get 57, and there's your answer. Okay. All right. So now we're going to go all the way back, the first page of the section. We're going to go to problem 44. So again, we're going to be turning here back and forth a little bit. Okay. So got a few more problems to do, but like I said, I think these are easier than the couple sections we've done already. 44. I really don't think I need to do the whole problem, but let's start it out. a rectangular window. It's 59.1 times 72.3. Again, it doesn't have to be a perfect drawing. It doesn't have to be drawn to scale or anything like that. So I'll put the shorter side as 59.1. Longer side is 72.3. Okay, and you're actually going to solve this exact same as what you did up here. Okay, it's just a rectangle. You could label the opposite sides, then add them all up, or you can do formula for the rectangle. Okay, and I said I probably didn't need to do this, but I'll give you an example here. So 2 times 59.1 is 118.2. 2 times 72.3 is 144.6. You add them up, and you get 262.8. Now again, you could have got that if you would have just took 59.1 plus 72.3 plus 59.1 plus 72.3. That would equal the same thing. Okay. 45, it's a slightly different problem. Now, don't read this too quick and think it's like the other square problem we did. The other problem with the square gave us a side and we had to find the perimeter. Here we have a square, but don't read this too quick and think the side is 20. It says the perimeter is 20, and we want to know how long the side is or how long each side is. So if we label this S, okay, the perimeter equals 4S. Well, the perimeter is 20, so we got to think of 4, I don't need parentheses if we're using a variable, 4S. So we're thinking 4 times what equals 20. So you could probably just do this one in your head, or if you remember algebra, you do the opposite. So you divide by 4. So S equals 5. And you could have even guessed and checked that. You could just guess as a 5, 5, 5, and 5 all the way around. Yeah, that would add up to 20. So that's the main thing on that problem is don't just say, oh, square and 20, each side's 20, so the perimeter is 80. Okay, the perimeter is 20. You have to find out how long each side is. Okay, we are now going to turn the page and go to 49. The reason we're doing this one is because it's a two-step problem. So the first part is nothing new from the other problems we've done. You got a rectangle, a wooden fence. It's going to be built. It's 46 by 58. Shows how many meters of fencing, and always make sure the units match up. So how many meters, and that they gave you meters, so that matches up, will be needed. And then the second part, if the wood for the fence costs $21.75 per meter, what will the wood for the fence cost? So the first part, so what we need to do first is we're going to go 2 times 46 plus 2 times 58. Figure out what that equals. So we got 92 plus 116 equals 208 meters of fencing. Okay, so we can cross, if we're pretty sure we did that right, these two can be crossed out. Okay, now the next thing is it costs $21.75 per meter. So for every meter we have, we got to pay $21.75. So we have 208 meters. For every one of those, it's $21.75. So we're going to multiply. And when we multiply that, we get 4,524. And so our answer is C. Okay, so that's why we did 49, because it's a two-step problem. So that's the first step. Second step is multiply. Okay. All right, now we're going to start looking at circle problems. Before we do our first problem, just want to go over some notes here quick. So we'll put those at the top of this page right here, I think. So circumference of a circle. Okay. Basically, circumference is just a fancy word for perimeter of a circle. Okay. So that is distance around a circle. So again, it would be like if you had to put a fence around some sort of a circle ring or something like that, that would be the distance around. Okay, so there's two ways that we can find this. So you need one of two bits of information. You either can use the radius, which is the distance from the center of a circle to any point on the outside of the circle, or you can use the diameter, which is the distance from a side to a side going through the midpoint in the middle of the circle. Okay, so you either use R or D. Okay, if you have R, the common formula used is 2 pi R. If you have D, the common formula used is pi times D. And you're going to, unless otherwise stated, use 3.14 for pi. So that should look familiar. Now the reason you can use both of these is because, now remember, this is when they're next to each other, it's multiplication. So you're taking 2 times pi times R, but you don't have to do it in that order. If you take 2 times R, that gives you D, because R is halfway. So 2 times that would give you all the way across. So that's why 2 times R times pi is the same as D times pi. Now again, just algebra books just write them in this order. You could definitely write 2R pi and D pi. Okay, I'm just writing them the way the books do. Okay, so that is basically the formulas for circumference. So now let's look at some problems. We'll come back to 46. It's a little more involved. So we're going to look at 48 first. I think we have 5 problems to go here and we'll be done. So this is just a simple one. It says find the circumference of a circle with a diameter of 13. Use 3.14 for pi. Now you wouldn't have to draw a circle if you really understand what's going on, but you have, they give you a diameter of 13. Okay, so the formula is what they say, pi d. Now a lot of times I'll just switch to order in this. So if I want to find the circumference, I put the number first. You could write out pi like this, or you can change it right away and write 3.14. Okay. Either way, you multiply, you're going to get 40.82. So that's the distance around the circle. Okay. So that's kind of a basic one using a diameter. We're going to, again, turn the page. We're going to find problem 60. So I'm going to turn a couple pages. Okay. The reason I want to do this one is because we did a basic one with a perimeter, or sorry, with a diameter. Now we're going to do a basic one with a radius. So the difference here is it's the same question. It says find the circumference of a circle, but instead of the other problem gave us a diameter, this gives us a radius. So the difference is that's a 4, and that's halfway across. So you could use this formula, 2 pi r. Again, I'm going to change the order. The 2's there. The radius is 4. And then pi is 3.14. Okay, so I just changed the order. Okay, so then you just multiply all these. You don't have to show this step. I multiply 2 times 4 is 8, and then times 3 times, or whoops, thinking 3 and writing, trying to write a parentheses. 3.14. You multiply, you get 25.12. Now you definitely could just in your calculator hit 2 times 4 and then times this, and you get the 25.12. Okay, so that's number 60. Now we're going to flip back. So that I just wanted to do a basic one with a diameter, a basic one with a radius. Now we're going to go back to 47. Again, this would be easier if they were in order, but I want to go over certain problems, easier ones before we look at a little more difficult ones. 47 is basically going to be exactly the same as 60 that we just did, but you might not understand it by reading the problem. So I want to read it so you understand. A picture is going to probably help in this. It says the minute hand on a clock is 5 meters long. What distance does the tip travel in one complete rotation to the nearest centimeter? So a couple of things what this means. You have a clock. It says the minute hand, which would start in the middle and goes somewhere towards the outside, is 5 centimeters long. So they really don't say, but let's assume the minute hand goes all the way to the edge. They probably should say that. And that's 5 centimeters long. Okay. So the picture looks just like what we did, but they don't ask what's the circumference. But that's what they're looking for when they say, what distance does the trip travel? So I guess it doesn't even matter if it's at the edge. They just want to know when it follows its circle, when this moves around, how far did it travel? So what it's asking, when this makes, let's say there was a pencil lead on the end of this, and as it went slowly, it would take an hour to get around. As it goes around, it draws a line, and it would say, what's that distance? So it is looking for the circumference. So all you're going to do for that one is exactly what we just did. And I think I might actually let you just finish that problem. So you would use this formula, and you go ahead and finish that problem. Okay, the way we just did on number 60. 2 problems left. So again, to finish this one off, you would put 5 in for here, and for R, multiply and find your answer. Also, I do want to go over, let's just finish it because there's one more thing I just want to talk about here. So if I change the order, 5 is the radius, we'll put 3.14 in, we get 10 times 3.14, we get 31.4. Now you notice over there that that's not in the answers. Well, always make sure you read the whole question. It says to the nearest centimeter, which means the nearest whole number centimeter. So if we look here, number past it, if that's 0 to 4, this stays a 1, which it does. Okay, so there. Did another problem for you there. 2 left. One of the more difficult ones. It's not really difficult, but just a lot going on here. Okay, it says Barry is fencing the area shown below. If all measurements are given in feet, how many feet of fence will he need? Now, you see the answers have pi in the answer. I almost think this would be easier if they just asked for the feet and we just did the formula, but I'll show you it's not hard. to figure this out, but it just can be different. So the one thing we have to do, we have some missing distances in here. So let's find what those are. And we can't, there's enough given information here to know how to figure this out. So we have a 4 here. We don't know this length right here. Okay, and then also over here, that's not given to us. Now don't just look across and say, oh, this is 5, so this is 5. No, it's not quite that simple. So let's look at this one first. Across the whole top, that's 8. Okay, so across this bottom, this and this make up that bottom. So we are 4 plus question mark should equal 8. Well, if we look at that, 4 plus 4 is 8. So that's a 4. Okay, here, from here, let's look at this side. From here to here, okay, should be the same as this question mark plus 3. So question mark plus 3 should be the same as 5 plus 4. So question mark plus 3 equals 9. So then question mark is 6. So this is 6. Okay, so if we go around here, let's start right here. And let's go this way and add this all up. And start looking at the perimeter. So we have 8. We go down is 6. Then we go over is 4. We go down is 3. We go over is 4. We go up to here is another 4. And now we have this last bit. Now this is where the real problem comes in. We have a half circle. So that's key, that it's a half circle. That's going to give us our perimeter. All right, so now, first step, I'm going to take all these numbers and add them up. So you can use your calculator, do it in your head, whatever is easiest. That's going to equal 29. Okay. Now, this half circle, there's a couple ways you can figure this out. Whatever this, what we have to pretend is if we had a full circle, we would know how to find that. Okay. We would take the formula of right here, pi times d. Well, our d, diameter of the circle, is 5 times pi. But now, since it's a half a circle, we need to cut that in half. And there's our answer, which is right here, letter A. Okay, if they didn't have it written as pi, then we would take 5 times 3.14. It's going to be a little over 15 divided by 2, and then add it to 29. Okay. We got one more problem to do, and now there's another problem like this that you should try. It's later on, and then check your answers. But the last example I'm going to do is, because it's just confusing on how, it's not a hard problem, but it's confusing on how it's asked. Number 54, last one. So the distance around equator of Uranus is about 160,535 kilometers. What is the equatorial diameter of Uranus? So it says use pi equals 3.14. So what happens is, it's like you had to cut, if you had a ball, but then you cut it in half. So a planet, you cut it in half. The equator would be the distance around, the widest part of that ball, or in this case, the planet. It's the distance around it. That's what the equatorial diameter is. Okay, so that's the part of this one that's hard to understand. Okay, then the next thing is, don't assume this number is a diameter or a radius. This is the circumference. They're asking for a diameter. Okay, so if we have a diameter and a radius or a circumference, we are going to use the equation, or start with at least the template of the equation. Circumference equals pi d. Now we're going to fill in what we know. Okay, so the circumference is, I did a mistake again. So is 160,535. We know pi is 3.14, or they tell us to use that. And we don't know the diameter. Okay, but now we can find it. Now guess and check would be hard on this, but remember, just simple, no, we haven't done algebra this year, but simple algebra would say if you're multiplying a number of times a variable and you want to find that variable, you do the opposite of what's being done. So you would divide each side 3.14. So you'd have the d left over here, and when you divide, you're going to get 51,125.79 something something something. Okay, now they just rounded, so we are looking at here, because again, if we're rounding the whole number, if I look at the next number, this is 5.9, this bumps up. Okay, so that would be the distance going through the middle from one side to the other. Okay, so kind of quite a few problems there. Some of them are pretty similar to each other. So at this point, you should go and practice some problems, check your answers. I think what I'll do, the last part here that I've been doing the last couple, is I'll go to the end here and just circle the ones we've done and show you what topics they're on. So we did 43. I kind of started 50. I drew a picture on that one. We did 61. We did 44. We did 45. 49. We did 48 and 60. We did 46, 47, and 54. So now again, the way you can use this is if you're trying a number, like if you're trying to do number 57 and you're not sure how to, you're not getting the right answer, you're not getting letter A. Well, we did two others in this category of objective 8, perimeters of a quadrilateral. So if you look at 43 or 61, one of those should help you figure it out. Okay, and then if not, if you still can't figure it out, that's when you ask me a question. Okay, it's important to ask questions if you're not understanding this. Some of you are doing that, not enough of you. So send pictures of these notes to me to get those points, practice some problems, then be ready to ask for a test. So, all right, if you have any questions, let me know.